Okay, so we've been talking about the process of transcription and translation, and we were on translation. So when the mRNA goes to the ribosome reads it, and it reads it by every three letters called a codon. The tRNA will come in and match the codon with an anticodon, and that will allow for an amino acid to come into the ribosome, because that's what tRNAs have on them. They have amino acids on them. And as a tRNA comes in, it will read the mRNA and translate it, bring in the amino acid, and then leave. And then a new one will come in, and so on. And these amino acids will begin to bond. They'll bond with something called a polypeptide bond. And then when these amino acids bond together, and at the very end, a bunch of amino acids together make up your protein. And then you have your protein, and that's what translation is. It's taking mRNA and translating it into making the proteins. All right, so we need to look at how do we determine, based off of the mRNA, what amino acids are there. So these two pictures are called the genetic code. We use mRNA to read this genetic code. So you won't need to memorize this, but it will be on the test and you'll use it to help you find what amino acids go with which codons. So remember, let's say this is our mRNA strand, AUG, CCC, UGA. Now we read it every three letters, and that's what we call the codon. So we AUG. So the inner circle for this A, first letter, so we would be working with just this section of amino acids. U would be the next letter. So now we're working with these four. So this is the U. So now we're just working with these two, and then G. So then G. So that would be MET. So MET would be an amino acid that codes, which is AUG codon. Then we'd have CCG would be the next codon. So over here, this is our first letter, so C. So we're going to be working in this column only, would be the first letter. The second letter would be this letter up here. So now we're just working with just this bracket, and then the third letter would be over here, which would be G. So now this would be the codon, and then pro would be the amino acid, proline. Now, if you notice that proline isn't just CCG, it also is CCA, it also is CCC, it's also CCU. So you need to know that one amino acid could have several different codons, okay? If you also look on this table, you can see some ones that only have one, like tryptophan right here. Tryptophan only has one codon to code for it, and it's UGG. That's it. It does not have another codon. Same thing with MET. MET is only AUG. Same thing with this stop codon. It's UGA. That's it. So some amino acids will have multiple codons, like leucine. Leucine has 1, 2, 3, 4, 5, 6 different codons to code for just a leucine. Okay? And then if you do UGA practice, what do you think UGA amino acid is? It's stop. So this would be how you would practice using genetic code and finding out what amino acids go with it. So the last part of learning was talking about mutations. Now sometimes when we take DNA and we transcribe it in mRNA, we can make a mistake. And mRNA could be transcribed not right. And so, but I want you guys to know that most mutations have little or no effect on the protein. Most mutations have no effect because most of the time it's just a letter change, but it still codes for the same amino acid. Because, like, let's say it was CCC and a mutation changed it to CCA. Well, CCA still codes for proline. So it still was the same protein. It just got one mixed letter mixed up. It was a substitution, but it still coded for proline, and so it still was the same protein. So let's try to see what is this type of mutation. So here's our normal DNA strand. This is our normal DNA strand, AACTTGCAAT. That's only one half of DNA. Now here's the mutated strand, AACTGCAAT. What would we call that type of mutation? Well, we call it a deletion. The T, second T, got deleted. And so everything frame shift and moved over to the left. Now, this is probably going to be a mutation that's going to really change the protein, but be aware most mutations don't have an effect on the protein. So in order to be successful, I think you should read over all of chapter 12 and 13.1 through 13.3, but be careful about the protein synthesis. Please make sure you go over your notes, you review the protein synthesis monster lab, and then go over the transcription translation practice problems that you did, review the genetic code, and don't forget about root words. Some types of root words you saw were trans, script, poly, anti, sin, ace, os. Those are some of the root words that could be chosen for the test. Good luck.